talk through what we had so we can look at this back again tonight if you want to go over it. Start by drawing that crosshair there. So then when you put your tracing paper over it, you trace the crosshair and the shape, and then you can just rotate it. Remember, it says anti-clockwise, so it needs to rotate like that once, so the crosshairs cross each other once, because that's split into 90, 180, 270, 360. Okay? First things first, this question tells me you will be assessed on the quality of your written communication. We've already discussed that means that it will be worth 2 of the total marks. Do we need to worry about that straight away? Do we need to write everything a big essay as we're writing along? The answer is no, you don't. Worry about just putting little arrows describing what you did after. Don't worry about it, do the maths first, that's more important. So, Alice earns £1,320 per month. She must spend 6/11 of that on her monthly income on rent. She spends 85% of the remaining money on food, bills and clothes. She saves the amount that is left in order to buy a computer. She wants to buy a computer which costs 400 quid. She already has saved 130 quid towards the cost of the computer. After how many months will Alice be able to buy the computer? Well, the first thing I've done is I've worked out 6/11 of the amount that she earns there. Okay, so the way that you do that is you always do that number divided by the denominator here. So I needed to see 11 divided by, sorry, the other way around, 1,320 divided by 11. So that's what I've done by here. I set up bus stop division. Okay, so I've counted how many 11s go into 1. The answer is none, so I just left that blank. Then I looked at 11s into 13, which is once, remainder 2. And then 11s into 22 is twice. And then 11s into nothing is nothing. Okay, so my answer is 120. In terms of what I did next, I times that by 6. Can anyone tell me why I times that by 6? Good, because it's 6/11. If I just divided by 11, I would have found 1/11. So to find 6/11, you just times by 6. So 6 times 12 I knew was 72. And I'll just pop that 0 on the end there, and I've just referenced this is the income spent on rent. Okay, and this is how I started getting my QWC, by putting pound signs there, if it's money. If it was kilograms, I just put kilograms after it, and then just saying what it is. Okay? The remaining money, I worked out by doing 1,320 minus the 720 I've just found out that goes on rent, and that left me 600 quid that's remaining. Now, I know that she spends 85% of that £600 on, what was it, food, bills and clothes. Now there's loads of different ways you can work this out, but what I spotted, because this was 100, I know that 85% means 85 and 100. So in 600, I just need to times the 85 by 6. So you can see by the side, I've done that by multiplying by here. But Miss said to Lloyd, you could find 50%, then you could find 10%, 5%, 20%, and put all those together to get 510 a different way. Absolutely fine. There's loads and loads and loads of different ways to find different percentages, whichever one works best for you. And again, I've made sure that I put the pound sign there, and I've just referenced what that is. That's money that's spent on food and etc. And the reason why I've underlined spent a load of times was for the next line. I know that she had 600 quid left, but because she spent it, that's suggesting that I'm losing that money, so I'm subtracting it. I think it's frozen there, isn't it? Oh, there we go. It's caught up. That suggests I'm subtracting it, so 600 take away the 510 that gets spent on food, etc., leaves me 90 quid a month that I can save towards the computer. So already saved is 130 quid. And then by the end of month 1, which is hopefully going to pop up on the screen in a second, by the end of month 1, I'm going to have 220 quid because I'm just adding 90 every time here. Then at the end of month 2, I'm adding 90 again because she saves 90 quid a month. You get 310. And then at the end of month 3, it's going to be the 400 quid. So it's going to take 3 months to buy the computer. So the first thing I've done is I've gone and highlighted letters that I can see within these parallel lines. So as soon as I've got parallel lines, there's 3 letters that we're looking for. Actually 4 that you can get. So you can get, if I can write them down by here actually, just turn my pen on. No. Alright, so you can get Z angles, you can get F angles, and you can get X angles. And the thing about all of those types of angles is they're equal. Okay, so I'm hoping that's going to work now. But you can also get something called C angles. And C angles are different, they're not equal, they add to 180 degrees. Okay? So in terms of what I've got here, I've got C angles here, and the definition that I need to know is C angles is co-interior angles add to 180, but it hasn't said anywhere in the question that you actually need to give reasons for your answer, I don't believe. No, it's not. So you don't need to know that definition, but you need to know that if you see a C, the angles add up to 180. So I did 180 take away the 110 to work out that was 70. Okay? The other angle I was able to work out straight away was the Z here. Now Z angles, we've already talked about, are equal. Angles are equal. So those two there have got to be the same. Okay? Now the next bit of maths I used was angles on a straight line add to 180. Because I knew that was 32 and that was 110, then it meant that I could work out the 38 by doing the following maths. 110, add the 32, which came to 142, and then subtract from 180 because angles on a line come to 180, which gives me 38. So that top angle there is 38. Now you'll see I've gone and made these lines here a bit more bold. They were given, but I've made them really, really stand out. Is there any reason why I've done that? Underneath these dashes, these two angles are always the same. So what I did next was, because angles in a triangle add to 180, I subtracted that top angle from up there. So I knew these two angles here added up to 142. And because they're both equal, I divided by 2 here. And half of 142 is 71. And I've just referenced there because of isosceles triangles. Now, what I've done here with these explanations is similar of a QWC question, and it really wouldn't surprise me if that was worth 6 marks, and they did ask me to do it through QWC. Okay? So if that was a 6 marker with QWC, I think I would have got those marks as well, because I've described everything that I've done. Okay? First, this one here, it says, given that W over 4 minus 7 equals X, find W in terms of X. So that means we need to get W on its own. When it says find W, get W on its own. So the first thing I've done is I've got rid of that minus 7. I've taken it over to the other side where it's become plus 7. But that's still not W on its own. It's still got this over W. What does over W mean mathematically? Out of, not quite, not far, not out of W, but out of, no, 4, because it's got a 4 over it. You're thinking percentages, Miles. This over 4 bit, if I take that round to the other side, what does that become? What is it doing to the W there? For instance, if I wrote something like 12 over 4, what would the answer be to that? 3. So that basically, fantastic. That 12 is getting divided by the 4 here, so if we took it over, it would be times in by that. Okay, so when I took that 4 over, it became times, but there's both of these things here. So what I did was I made sure I put those in brackets to make sure both of them got multiplies. Okay, you don't necessarily need to write this line that I've written here. You can skip straight to this bit here, but don't forget to multiply both the X and the 7 by 4. Because if you do that, or if you don't do that, it'll be wrong. Okay, it has to be that you times the X and the 7 by that 4. Okay. This one says, Anwar went shopping to buy a book and some CDs. He had exactly £60 with him. In one shop, he bought a book costing £15 and some CDs. So we don't know how many CDs he bought. Each CD cost £7, and he paid for these items, and he was given some change. So he definitely has some money. Anwar bought N CDs. Write down an inequality. So when we're talking about inequalities, we're talking about less than or greater than or less than or equal to or greater than or equal to. Okay, that's what an inequality is. Satisfied by N. And what is the greatest possible number of CDs he could have bought? So I started this off, I did 7N. Can anyone tell me why I did 7N? Looking at the colour of the highlighting here to the colour here. Meg? Good, there's £7 and he bought N of them. So if I bought 1 CD, I would have paid £7. If I bought 2 CDs, £14 and so on. So I'm timesing by that 7, that's why it's 7N. Why have I added 15? Good, that's how much the book costs. And why have I said less than 60 quid? Excellent, Joel. Because he gets some change, so it's got to be that he spent less than 60 quid. If he spent exactly 60 quid, I would put equals 60. Okay? So from there, what I've done is I solved this, and it's very, very, very similar to solving an equation. So what I did first of all was I took that plus 15 over to the other side, where it's become a minus 15, and 60 minus 15 would be 45. The next thing I've done is I've done 7, I've taken that over. Now that's currently timesing by the end, so when that goes over, it'll become divided by the 45. Now 7 doesn't actually go into 45, so what I wrote down next was n is less than 6, but you would also have £3 remaining. So if I have 45 quid and I bought a number of CDs that cost 7 quid, I could have got 6 of those maximum, and then I'd have had £3 change. Okay? Now the final question is, it says, what is the greatest number of CDs Anwar could have bought? So my answer is 6. That's the greatest number of CDs he could have bought. So, explaining through the first one here, I'm going to go through these just where the empty spaces are. So how did I get these numbers here? Well, because I was told what the nth term is, the way that you generate the terms of that is that you sub in where we are in the term. So this number here being the first number, I just substitute 1 into that. So I do 8 times 1, which is 8, and then take away 3, which is 5. So my first term is 5. To find my second term, I substitute in the number 2, because it's the second term. So 8 times 2, which is 16, take away 3, which is 13. Then, third term, 8 times 3, take away 3 is 21. And then if you notice, these are going up in 8s. Okay, and that's not a coincidence, they should be going up in 8s, because it was 8n. Okay? For the next one here, I've written it out by here. The way that I teach this, if you're doing it a different way and you know how to do it, then ignore my way. But the way I do it is I have a look, see how much I go up in every time, which is 4s. And because every single number is 4, I'd write that as 4n. If it's going up in 5s, I'd say 5n. If it's going up in 20s, I'd say 20n. And then to work out what number gets plonked on the end of it, I come and find the number in front of the first term. That's why I've done it in a different colour. So if I'm going up in 4s this way, then I must be going back in 4s this way. So that number, 9 take away 4, is 5. And what sort of 5? It's a positive 5, so positive 5 gets plonked on the end here. So my nth term there is 4n plus 5. So these two here are grade C questions. This one here is a grade B question. When we get to what we call a quadratic sequence, where it goes up in odd numbers, that gets to being an altogether harder topic. If you can start to get some of the marks of this, we'll be chuffed to bits, okay? But you're looking at probably about 1 mark there, possibly 2 there, and then definitely 2 here, if not pushing 3 marks to this one here, okay? Now the way that you do it, I start to do it here. Here's my original sequence. I just copied out exactly the same sequence. Forget what's going on up here for the moment. What I did was I looked to see how much I go up in between these terms. So can you see I go up 3, then 5, then 7, then 9. Now that's what we call the first difference. If you look at 3, 5, 7 and 9, I have a difference of 2 between each of those there. Now because this is always the same number, not because it's 2s, but because they're all the same number, that tells me it is an n squared sequence. Okay? Ellis, what did I just say? Number that goes in front of the n squared by picking that number there, and you always divide that by 2 no matter what it is. So if it was a million and a million divided by 2 would be 500,000 or 500,000 in front of that bit there. Okay? But in our case, it's 2 divided by 2, which is 1. 1n squared is the same as just saying n squared. Okay? Now, how do I go and work out that's minus 1? What I do is I go above my sequence. So this thing here was my sequence that I was given in the question. And I write out what n squared is. Now, n squared is a shorthand way of saying the square numbers. So this is 1 times 1. This is 2 times 2. 3 times 3. 4 times 4. 5 times 5. And I've had a look to see what I do to 1 to get to 0. And the answer is I take away 1. 4 to 3. Again, I take away 1. 9 to 8. Take away 1. 16 to 15. Take away 1. 25 to 24. Take away 1. So every time from my n squared, I'm taking away 1, so that gets written on the end there. So I've probably written, hopefully, nice and neat in the box here, that 2 divided by 2 is 1n squared, or I've just left it as n squared, and then the take away 1 by there. Okay? But these are tricky the first time you see them. They are very, very, very repetitive. So by all means, if you want to, we can practice and do a couple of sequences on the board and just get the idea of being really, really certain on it.
Okay, you have to express 240 as product of prime factors in index form. Okay? Okay, remember, it's 3 marks this question. So the product, the prime factors, and the index form, okay, is your 3 marks. First of all, set it out in tree diagram form. I think everyone's using tree diagrams. Are they in the room?
No.
No?
No.
Okay. Great, okay, so you're happy with it. Okay, so tree diagram method. You split 240 into whatever you can. Okay, it ends in a 0, so 10 is a nice place to start. So 240 is 24 times 10. You then look at this number and think, can I split these into anything? So start with 24. 24 is 6 times 4. Then you're left with these two, 6 and 4. Think, can I split these two into something? 6 I can split into 3 times 2. 3 and 2 are prime numbers. If you look at the top where you listed the prime numbers, 3 and 2 are prime numbers, so we circle them. 4 is 2 times 2. 2 and 2 are prime numbers, so we circle those. So you've got the 10 then. 10 is 5 times 2. And 5 and 2 are prime numbers, so we circle those. So altogether we've got our prime factors 3, 2, 2, 5 and 2. The question's asking for the product, and product in maths is times, you multiply them. So all that means is you multiply all the prime factors together. So we just multiply these together. It's good to do them in ascending order for the next bit, okay? So 240 equals 2 times 2 times 2 times 2 times 3 times 5. Okay, have a quick check, make sure you haven't missed any.
Sure. You know when you put the 1 in the...
Okay. So the next bit then, it says in index form. So that's just another word for use powers. So we've got 1, 2, 3, 4. So 2 to the power 4. 3 to the power 1, or you can just leave it as 3 times 5. Make sure you put the times signs in between. People do lose marks by not putting the times sign in between. Okay, the next bit then. Part B. Part B's in these questions, normally they're trying to make you do something else with it. Okay, in this case they're saying, use this answer here to try and find 240 squared as a product of prime factors in index form. So all it means, when something's squared, you put all of this number squared. So then what you've got to remember then is the rules you've got for indices. If you have a power to a power, you multiply each one of the indices. So as 2 to the power 4, you do the 4 times 2, which is 8, 1 times 2, which is 2, and the 1 times 2, which is 2. This is why, for this sort of method, it is worth putting them down as ones. You're not going to lose a mark for it. You won't lose a mark if you don't have it, but it helps you on any next bit you might be looking at. Okay?
Okay, question 8 says, Ellen has 2 bags of coloured balls. The first bag contains only red and green balls. The second bag contains only yellow and purple balls. Ellen chooses one ball at random from each bag. The probability that she chooses a red ball is 0.8, and the chance that she chooses a yellow ball from the second bag is 0.3. So what I've done is I've set up probability trees. The first one I could either go on red or green, and I had a 0.8 chance of going red. So because probability trees add up to 1, that meant that must have been 0.2, because 0.8 add 0.2 is 1. Similarly, with the yellow and purple, then it was 0.3, I could get purple. That meant it must, 0.3 I could have got yellow. So it's 0.7 I could get purple, because 0.3 add 0.7 is 1. And that's exactly the same options here. And you'll notice in highlighter, I've gone and followed the path they said. The chance she gets a green ball and a purple ball. So that was green followed by purple, and you multiply between the branches. Now be careful, 0.2 times 0.7 looks like 1.4. But all probabilities add up to 1. 1 is the same as a whole, which is the same as 100%. So it can't be bigger than 1. And actually, it would be 2 times 0.7 that is 1.4. So 0.2 times 0.7 is actually 0.14. Okay? If you want to, you can think of it as fractions. It's like 2 over 10 times by 7 over 10, which would be equal to 14 over 100. And then 14 divided by 100 is again 0.14. Okay? So a couple of different ways to work that one out.
Central enlargement, okay, when you have to find a transformation. We don't know it's an enlargement. The fact we're saying it's an enlargement is because it's going from a small one to a big one, okay? Be careful what the question says first, alright? Sometimes they can mix them around, okay? It says triangle A onto triangle B. So we're going from A to B, so we're getting bigger, alright? So it's an enlargement and it's getting bigger, alright? First thing you can do is find the enlargement. So if you look at the squares, it's going, find something you can easily count. We're going 3 across to 1, 2, 3, 4, 5, 6, 7, 8, 9 across. It's going from 3 across to 9 across. Then you're going to be times it by 3, aren't you? So the scale factor is 3. Okay, so we've got 3 marks, and so far we've got 2 bits of information. It's an enlargement for 1 mark, and it's going by a scale factor of 3 for the second mark. For the third mark, you need to find the centre enlargement. It doesn't tell you to do that, but when you have an enlargement, you've got to find the centre enlargement. Okay? And the way you do that, if you see what we got on the screen, we get a ruler and we join all of the equivalent corners together. So we get a ruler and we just draw a line connecting the equivalent corners together, corresponding corners together. And we keep going until they cross over. And every single line will cross over at a set point. And that point where they cross over will be the centre enlargement. But you can't just leave it with a blob like that. What you need to do is underneath it then, answer the question. So you say, it's an enlargement, scale factor of 3, and a centre enlargement 411, and do it as a coordinate. Okay, so don't even just put a blob there and put like COE next to it. You've got to actually say the centre enlargement, or the centre, or COE, whatever you want to call it, and put the coordinate as 411. Okay? Alright, so you have to write that number in standard form. Okay, there's the answer there, but let's go through how you get there. Okay? So what you do, we're trying to make a number. Standard form has got a number that's bigger than 1, or 1 or bigger, and less than 10. So really between 1 and 9.9. Okay? So we've got to put that dot, decimal point, between a 3 and the 8 to make it 3.8. The way I do it is by that dot there, we move it once, twice, 3, 4, 5, 6, 7 to get to that point. Okay? So that dot there is moving 1, 2, 3, 4, 5, 6, 7. Okay? So it's moving 7 places. So we're going to make it 3.8, because what we got there. And it's times 10. Because it's moving as a small number, the small numbers are negative. So it's 3.8 times 10 to the minus 7. Okay? For the next bit, the next question, it says evaluate. Evaluate is just another way of saying work out. Okay, calculate, evaluate, same sort of thing. Okay, so you've got to work that out and give your answer in standard form. The best way to do this is to change the 9,000 to standard form first. So 9,000 standard form. Again, we want to make it, instead of a number 9,000, we want to make it a number between 1 and 9.9. So we're going to move the decimal point to after the 9 to make it 9.0 and 9. Okay, so the decimal point is there at the end. 1, 2, 3. It's a big number, so that'll be 9 times 10 to the power 3. So we change the equation, or we change the sum into that. So 1.4 times 10 to the power 8 times 9 times 10 to the power 3. And what you do is you multiply 1.4 and 9 together. You do the numbers separately. So 1.4 times 9 is 12.6. And 10 to the power 8 times 10 to the power 3. When you multiply with powers, you add the powers together. Okay? So 10 to the power 8 times 10 to the power 3. 8 add 3 is 11. So it's 12.6 times 10 to the power 11. What you need to do then, to get the full marks, is realise that this number here isn't the standard form. It's bigger than 9.9, isn't it? So you've got to change that in standard form. And one way of doing that, or the way of doing that, is you think, how do I make 12.6 to what I want it to be? So 12.6, I divide it by 10. So if I divide 12.6 by 10, I get 1.26. To keep it so we don't change the equation at all, we don't change the number. So we don't change the number at all. We divide that side by 10, we multiply the other side by 10. So 10 to the power 11 times 10 becomes 10 to the power 12. So the answer will be 1.26 times 10 to the power 12.